We are looking at the tool set of problem solving, and very specifically in this particular tool we are looking at what to do when we get stuck. Yeah, so suppose you are having a problem which you're trying to solve, and you're applying the universal law of problem solving and using the generic approach, universal approach of problem solving, which we have learned in the previous two tools. And you're making your best attempt, and even though these are universal approaches, even after applying it you get stuck. Yeah, what to do when you get stuck, despite of using the universal law and a universal approach. Okay, now in this section we'll try to understand why do we get stuck, when do we get stuck, and most importantly what to do when you get stuck. Okay, let's look at an example. So in this diagram shown below, the number in each box is obtained by adding the number in the two boxes immediately underneath. So for example, if you are asked to find the number in this box, you need to add up the numbers in the two boxes below it. Yeah, suppose if you are asked to find the value of this box, then it can be obtained by adding the numbers in the two box underneath it. Now you need to find what is the value in the topmost box. You need to find the value in the topmost box, and we know that the numbers in some of the boxes are already known to us, which are these. You need to find this one. Okay. Now we this per se seems to be a difficult problem, so let's apply the universal law of problem solving and try to find a similar but much smaller problem that we can solve. Yeah, suppose if instead of this big structure, if you had a structure like this in which there is one box on top of two, a very smaller problem, smaller set of this bigger problem. Now out of these three boxes, if we had known the value of the 2 in the bottom, then we could have easily found the value for the box which is sitting on the top, which means it's a much easier problem that can be solved. Likewise, if instead of this three, if you had got these three boxes in which the value on the top and the value on the right bottom is known, you could have found the value in the left bottom by subtracting this value from that value. Yeah, so you can still find the third box which is missing in number. You can obtain it by subtracting the number here from the number there. And likewise, if we had a box structure like this in which these two are known, you could find the third one by subtracting this one from the top box. Okay, so the generic approach, the universal approach of problem solving is basically, if you remember, is to is to extract the information which is now in the form of a diagram or table, and start identifying a starting point. A starting point, as you all know, is the first step, the very first step, the easiest step to be taken based on the information which is available to you. So let's look at what could be our starting point. So if you look at this structure carefully, we'll try to find a set of three blocks which are of either of these three shapes, so that very easily we can you know the value of two boxes, and the third one you can find. Yeah, so if you look around, there are two such starting points. If you look at this particular set of three boxes, we know that in the bottom two boxes we know the values, so the third one can be found by just adding these two numbers. It is of this shape. So we'll add 3 and 4 so as to get the value of 7. Likewise, if you look at this set of three boxes, it is like this one, wherein 2 are known. In order to find this value, you have to subtract the one on the left bottom from the one on the top. Yeah, so we'll subtract 1 from 9 to get the value here. Yeah, so as per the generic approach of problem solving, what we have taken the initial couple of steps, and our intention is basically to build upon it, start filling in the rest of boxes and approach our objective, which is to find the value in the topmost box. But we have a problem here. The problem here is that after filling these two boxes, there is no such set of three boxes which are of either of these three forms. Yeah. So if you look at for example, if you look at 38, and if you look at the 38 which is sitting on top of the other two boxes, it's only one value out of three that is known. we don't know the value of these three. Yeah, likewise, if you look at this 38 from the perspective of this three set, it's only one out of the three which is known. Yeah, had we known two out of three, then we could have used this smaller problem to fill the third, but it's not the case. Yeah, so we have reached a situation wherein all the set of three boxes which are touching each other are of this form. Yeah, either we only know the top value, not the bottom two values, or we only know the right bottom, as in case of this 38, as in case of these three boxes, and we don't know the other two, or we only know the left bottom but not the other two. So it's like this 9 which is part of this, which we can't find. So here we are genuinely stuck. Yeah, so in our journey, we have identified the starting point, we are moving towards objective, we are taking step by step approach to our objective, but we get stuck because beyond a point, we cannot take the next step. Yeah, so in our journey, in the generic approach to problem solving, we have hit a brick wall. When does this brick wall appear? It is when all the information that is available at your disposal, you are using all of it, but still you are not able to make progress. So you have exhausted all the information available to you, and you can't proceed further. That's the time when you get stuck. So, what do we do when you get stuck? I mean, one the easy option is basically just to say that no, I give up and leave. But for the genuine problem solvers, that's not an option. When you get a brick wall like this, what you typically do is basically you get hold of either a ladder to overcome this brick wall, or you dig out a tunnel below this wall to overcome it. Once you are able to come to the right side of the wall, your journey becomes smooth. Okay, this, in the parlance of problem solving, is what we call as an assumption, making an assumption. Whenever in your approach to problem solving, if you get genuinely stuck, wherein all the information available at your disposal is exhausted and you're not able to progress further, that is the time to make an assumption. An assumption is basically equivalent of building in a tunnel, digging in a tunnel, or putting a ladder on top of this brick wall, so as to overcome this hurdle. So let's take in now the important thing here is basically when you're making the assumption, you have to appreciate that making an assumption is a very courageous and a bold step. Yeah, if you're facing the brick wall and you know that you have to either dig a tunnel or move in a staircase here, your mind will start playing with you. It will all kind of negativity will come to your mind, saying that, no, what's the point in dragging the staircase all the way from wherever it is kept to this point, or what's the point in digging a tunnel? You may as well give it up. But making an assumption, the taking the effort of dragging in the staircase up to this point is a must. Yeah, you have to make an assumption, otherwise you'll not be able to progress further. Yeah, you have to overcome your mental block in terms of making an assumption. Now, how to handle your negativity, how to handle the inner voice which is pulling you down, is something which we'll be covering in the course later. It will be covered as a separate tool, but for the time being, just take it that you have to overcome the mental block of which is discouraging you from making this assumption. So let's come back to our problem. Yeah, so we've hit the roadblock. We are not able to find any triplet of blocks which is of this nature. So we have hit the roadblock, and we know that we have to make an assumption. Let's assume that the value in this particular rectangle is a. Let's assume that the value is a. As soon as you make the assumption, your mind will start playing that, what's the point in, well, assuming it as a. We are anyway not able to find what we're supposed to find, that is the objective, which is already an unknown to us, and on top of it we are introducing another unknown. How will I find the value of a? What's the point in introducing a wherein there is no visibility as to how will you find the value of a and how it will help us in terms of achieving the objective. You have to overcome that mental block and proceed with your assumption. As soon as you assume this as A, then the way forward becomes slightly easier, because now if you look at this set of three blocks, two of them are known and the third one can be found. Yeah, so you can put the value here as 9 plus A, and then so which means you have taken another step in your journey towards your objective. Let's look around. Can you figure out any other block which can be filled? If you shift our attention to the next set, in these three blocks, two are known. So it's a pattern like this. The third one can be found. So from 38, if you subtract A, you get 38 minus A. Yeah. So which means you have taken another step. Let's carry on. Let's build the momentum. Yeah. And then if you look at this block of this set of three blocks, these two can be added up to get the value here, which is 45 minus A. And then you keep on taking next steps. Here again, it's a pattern like this. When two are known, third can be found. You add 38 with 45 minus A to get it here. Then you shift our attention to the next step, which is to add up these two to get here. And then finally you have taken the journey from your starting point. You When you get stuck, you made the assumption and you have come all the way, filling in all the sections till you come to your objective. Now notice when when you come to the last step, the very last step, which is to add up these two to find your objective, what happens? This 47 plus A and 83 minus A, when you try to add it up, this plus A and minus A gets cancel each other out, and you get the number here, which is 130. The significance here is that all those mental blocks that you had in terms of introducing the assumption, how will I find the value of A, I'm not sure whether it will take me to the objective or not, all were unfounded. The fact is, the solution to this problem does not depend on the value of A at all. We have not even found the value of A. A could be anything, we have not even uh, bothered to find the value of A. In fact, like can take any of the infinite possible values. But the thing is, the point to notice here is you showed the courage to make the assumption and overcome that brick wall, and which cleared your journey towards your objective, and that allowed you to reach the objective without even bothering about this, without even knowing the value of A. Which means that the staircase that you had brought in was just a device, just a small step, just a small device which was there only to overcome the hurdle. You don't get stuck with that device. Yeah, you don't have to find the value of A here. It is just a device to take you to your objective. Okay. So as we have seen here, we got stuck somewhere in our journey from starting point to objective. We showed the courage. We made the assumption, which is equivalent of taking a tunnel or building a bringing in a staircase, and that allowed us to carry forward in our journey towards objective. So when do you make an assumption? When you have to make an assumption in your generic approach to problem solving, you have to make an assumption when you get genuinely stuck. Yeah, when I say genuinely stuck, it's not that you're not intending to solve the problem. It's not that you're not looking at the information given to you. When you have used up all the information which is available to you at your disposal has been exhausted, uh, you're genuinely lacking any additional information, that is the time when you have to make the assumption. Yeah, because your progress is stuck because all the information which is available at your disposal is exhausted, and there's no additional information which can allow you to take the next steps. That is the point wherein you have to make the assumption in your generic approach to problem solving. Now it's like the equivalent of it is your journey to the school. Suppose every morning you wake up, get ready, and start from home, and you go towards school. Yeah. I mean, the first step that you take is get hold of your Ferrari. Well, I'm assuming, I'm hoping, I'm wishing that all of you who are watching this video have got a Ferrari which carries you from your home to school. So you get into your Ferrari, which is the first step, and then you are moving in the right direction. You know what the direction is. You're using the generic approach, the universal approach of problem solving, universal law of problem solving. You're moving in the right direction. You are genuinely interested in reaching the school, but some point on your journey you get stuck because the fuel has emptied out. Yeah, it's not that you're not intending to go to the school. It's not that your intention was to bunk the school. It's not that you're deliberately taken the wrong direction. You are making all your efforts. You're moving in the right direction, but it's a general problem. If your fuel is empty, you can't help it out. Yeah, that's the point wherein you have to get some additional fuel and put it into your car, which is the equivalent of making an assumption, which is the equivalent of bringing in that ladder or digging in a tunnel to overcome the hurdle. Now, do you want to take another example of it? When to make an assumption, when you get stuck, how do you get stuck, and how to overcome it? Let's take another example. A sequence of numbers is a sequence of numbers of which the first is -5 and 26th is +2. There is a sequence of number given in which the first number is -5 and the 26th number is +2, and the sequence of number is defined by a rule, and the rule is that each number is the sum of one before it and one after it. Yeah, each number, so for example, if you have to find the fifth number, you have to look at the number which is in the fourth place and the number in the sixth place to and then add those two numbers to find the number in the fifth place. You need to find the 12th number. Yeah, you need to find the 12th number. Now, isn't it a difficult problem? Because you in order to find a particular value, you need to know the previous value as well as the future value. Yeah, so it's a generally difficult problem, but let's apply the generic approach to problem solving and make a good table. We'll this is all a clustered information, a clouded set of information. We'll put it down into a nice table. We'll draw a table which has got 26 segments in it. The first value we know is -5, so we'll put a -5 here, and the 26th value is +2, so we know that the 26th is our +2, and our objective is to find the 12th number. We need to find what is the value which is here in the 12th place. You need to find this particular value. Now, as I said, it's a genuinely difficult problem, because in order to find, so for example, what the rule says is, in order to find the eighth value, you need to add the value which is in the seventh place and the ninth place to get the value in the eighth place. Yeah, so it's like saying that in order to find what is my present, I need to go back in the past and what I was in the past. Not That's not sufficient. I need to go in the future and find what am I going to be to find what I am in the present. That's a generally difficult problem. It's a very difficult problem. Yeah. So which means there's it's not even it's not even that you are able to reach the starting point. Yeah, it's not here that you're able to reach the starting point. If say for example, if you try to solve it a similar problem which is much smaller in scale, if out of three consecutive blocks, any of these three consecutive blocks, if we had known the first and the last, then we could have added up the first and third to get the value here in the second box. Likewise, if we had known out of three consecutive boxes, if we had known the values in the first and the second, we could have derived the value of third by subtracting the value here from the value there. Yeah, you could have still managed to find a way out. Or otherwise, if you had in the three consecutive boxes, if you had known the values on the two right side, the third one you could have found by subtracting the one on the right from one in the middle to get this value. Yeah. So any of these three would be a smaller problem that could have been solved. But the challenge here is we don't have any set of three boxes in which any set of three consecutive boxes in which two are known. You can overlay these three patterns across it. You're not able to find. So for example, if you look, you know here -5 is known, but the two on the right are not known. Yeah. Likewise, two here, but two on the left are not known. There is no single collection of three consecutive boxes in which two are known, which means at the very first step you get stuck. You're not even able to find the starting point. As we know, which means you have hit the roadblock in the very first step. As we know that the brick wall that you may hit, it need not be after a few steps. It can be in the very first step. So in this problem, we have hit the brick wall in the very first step. Yeah. What do we do when we hit the brick wall? You have to show the courage and make an assumption. Make an assumption which is basically equivalent of taking a tunnel or bringing a staircase. So let's show that courage and make an assumption. Yeah, let's assume let's assume that the third number in the sequence is A. Yeah, which means we are assuming the value here is A. That this particular value is A. This is A. Now, as soon as when you're making the assumption, your mind will think as to, wow, what's the point in bringing in A? I don't know how well I find the value of A, and whether or not whether it will take me to find the 12th value or not. Overcome all those and show the courage on making the assumption. As soon as you've put in A here, this set of three blocks, this sort of three consecutive block becomes this, in which the first and the third are known. You can find the second. Yeah, you can find, you add up. The rule says in order to find a particular value, you need to look at the number before it and the one after it. So in order to find the second one, you need to look at -5 and plus A and add them together. Yeah, so that gives us A minus 5. Once you have fill in as A minus 5, and then if you focus your attention on this set of three consecutive blocks, it is a pattern which is like this, in which the first and the second are known and the third can be found. The third can be found by subtracting the first from the second. Yeah, so in this case of three boxes, what should be added to A minus 5? What should be this value? What should this value be, so that when you add it to A minus 5, you get A? Yeah, so the answer to it is, it should be -5. It should be +5. Sorry, when you have a +5 here, and when you add it to A minus 5, the 5 and -5 will cancel each other out, and you get A. Yeah, so you are able to take the next step. You're able to overcome the brick wall, which was not even allowing you to start. You made the assumption and you have taken the next step. Likewise, if you progress it further, this again, the block of three is like this, wherein two are known, the third can be found. And what should be here, what number should be here, which upon adding to A gives you 5? And that number should be 5 minus A, because when you add 5 minus A with a plus A and minus A will cancel each other out, and you'll get 5 here. You can apply the same approach to get the next step, which is to find the sixth term, and the sixth term has to be, what should be here, what should be added here, what should be the value here, which upon adding to 5 gives you 5 minus A. So that value should be minus A. So minus A, when you add it to 5, you get 5 minus A. Okay, and likewise you can keep on coming to the seventh step, which should be -5. When -5 is added to 5 minus A, the 5 and -5 cancel out, and you get minus A. So the seventh step should be the seventh number should be -5. And likewise, if you fill in the 8, you get A minus 5. Now at this point, once you have filled in this 7 or 8, you have sufficient filled all this information. It's always good to see what you're doing. Is there any pattern emerging? If you look at this seventh value, it's the same as your first value. And if you look at this A minus 5, which is the eighth value, it is the same as A minus 5, which is the second value. Which means after the first six terms, there is a repetition happening. Yeah, potentially there is a repeatable pattern of the first six numbers. These six numbers potentially may be repeating. Just in order to make sure that your conclusion is correct, or the hypothesis is correct, you look at the ninth place as well. In order to find the ninth place, what should be here, which upon adding to -5 should gives you A minus 5? So that should be A. It should be A. And if you compare it with the A here in the third place, your hypothesis is confirmed, which means your repeating pattern is conclusive. As soon as you know that this repeating pattern is conclusive, you don't have to individually calculate all of them. You can start filling in, you can just start applying this repeatable pattern in the next set of terms. So the next set of terms, the 10th, 11th and 12th will be same as 4th, 5th and 6th, which are these. Similarly, the 13th to 18th will be same as first six. Yeah, so the same pattern, you lift it, copy it over to here, and likewise you will keep on doing it for the next set, which is from 19th to 24th, and then 25th will be same as your first, which is minus 5, and 26th will be same as your second, which is a minus 5. Yeah, now, once you have hit the a minus 5, you observe something. The observation is this a minus 5 is actually equal to plus 2, because the 26th term is plus 2. So that gives you an equation. That a minus 5 is equal to 2, which can be solved for getting the value of a. So a minus 5 is equal to 2, which means a is 7. Once you know the value of a here, in this case, your assumed value of a you are actually able to find. Unlike the previous problem wherein you are not even bothered to find the value of that assumption. Here, you are fortunate enough to get the value of what you assumed for. Yeah, still your initial mental block of what's the point in introducing a, whether I'll be able to find the value of a or not, is unfounded, because eventually you are able to find the value of a. So once you know the value of a, then you come back to your objective. What was the objective? The objective is to find the 12th term, and the 12th term is actually equal to minus a. So the 12th term, which is your objective, is minus a, and hence because a is 7, the value of it is minus 7. So coming back to what we have learned, you have to make an assumption when you get genuinely stuck. When you get genuinely stuck, which means when you have all the information that is available at your disposal has been exhausted, and still you are not able to progress further. You have tried all possible things. You've correct. You're moving in the right direction. You're using the right tools of universal law of problem solving, universal approach of problem solving. Still, all the information was exhausted, which means there was a lack of information. An incomplete set of information, which you have to overcome by building the bridge, digging the tunnel, or bringing the staircase to overcome the brick wall, which in the balance of problem solving is to make an assumption.